Hello and welcome to section 4.7. Here are the solutions to 4.6. Guys had a couple proofs in there. I like these problems. This was kind of like the one from the video. Very far-fetched, but kind of fun. And then here I always go over these on my video. You're given that ABD is congruent to angle CBD, and you're given that AD is congruent to CD. Can we conclude that AB is congruent to CD or BC? So AB and BC. You have a reflexive side right there, so we have angle side side. That one would be no. Here we're given AC is perpendicular to BD, so those are all right angles there, and ADE. See, this triangle here is congruent to CDE, this one right here. Do you have enough information to show that AB and BC are the same? Those are there. So these two sides are congruent because they are CP-CTC, and this is reflexive here, and these are both right angles here. So these two triangles are congruent by side angle side, so that one would be yes. All right, and then BD bisects AC, so those are equal. AD is perpendicular to BD, so we have a bunch of right angles right there. And then we're looking for, again, AB and BC. So these guys here, that's reflexive. So again, side, angle, side, that would be yes. We could show that by CP-CTC. That is the answer, by the way, that the book provides. So I like my answers better, but you be the judge. All right, we're going to work with isosceles and equilateral triangles today. We're going to do some proofs with them. They're great proofs. So we're going to skip that and go straight to the base angles theorem. We've talked about this before. If two sides of a triangle are congruent, then the angles opposite of them are congruent. So if these two legs are the same, then the angles opposite of them are also the same. The base angles are going to be congruent. It's called the base angles theorem. The other angle, by the way, in an isosceles triangle is called the vertex angle. So let's get straight to the proof. We're going to construct an auxiliary line for this. And we're going to construct it perpendicular. We'll call this M. Doesn't matter. We're going to construct it perpendicular to LK. And I can do that because of the perpendicular lines theorem. So construct JM perpendicular to LK. And that is the perpendicular lines postulate. There has to be one line that's perpendicular to LK that goes through point J. Okay, we're given that JK is congruent to, let's write that down, JL given, and we're trying to prove the base angles are the same, so L and K are the same. Well, I'm going to call this angle 1 and angle 2. I'm going to say angle 1 and angle 2 are right. And that is definition of perpendicular lines. And then I'm going to say that angle 1 is congruent to angle 2. Actually, we're going to go with HL here because this is reflexive. So I don't even need to say that angle 1 and angle 2 are congruent. They're right angles, so we have right triangles. So I'm going to go with JM is congruent to JM. And that is reflexive. Okay, so now if I look at my picture, I have HL, so the two triangles are congruent by HL. And then CP-CTC says that angle L is congruent to angle K. So I proved the triangles are congruent to show that the parts are congruent. All right, and that is the base angles theorem proof. Basically, it's what we worked with yesterday, except for we have an auxiliary line. So now we're going to work with the converse. So it says if the two base angles are congruent, then the sides opposite are congruent. And so this is theorem 4.8, base angles converse. It says if two angles of a triangle are congruent, then the sides opposite them are congruent. So we're going to show that AC is congruent to AB. So again, we're going to construct an auxiliary line here. We're going to call this AM. Construct AM, and we're going to construct it perpendicular to BC. There has to be one line that's perpendicular to BC that goes through A. Okay, and then we're given that B is congruent to C, given. I got to show that these two triangles are congruent. Okay, so I have a reflexive side. AM is reflexive. AM is congruent to AM, reflexive. See what that gives us. Okay, I'm going to mark this here. Okay, so I have a side, and it's looking like I have the right angles. So we got to have angle, side here. So we're gonna call this angle 1 and this angle 2. I'm going to say that angle 1 and angle 2 are right angles. Definition of perpendicular lines. Okay, and then what I'm going to do is I'm going to say that angle 1 is congruent to angle 2. Right angles congruency theorem. And let's see where we're at here so far. We have these two angles are congruent, the right angles there. And then I have my reflexive side. And then I have my angle B and angle C that was given. So I have angle, side. So the two triangles are congruent by angle, side, which makes the two parts congruent. Let's see. So we are looking for AB and AC. CP, CTC. I showed the triangles are congruent, which makes the parts congruent. And that's it. There we go. We're done. Copy and complete this statement is kind of just some basic definition stuff. HG and HK are congruent. Then G and HKG. Notice how I didn't call it angle K because I don't know which angle K is. KHJ is congruent to KJH. Then we can say the opposite sides are congruent. HK and JK are congruent. So base angles and converse of the base angles theorem. And then these are two corollaries to the base angles and the converse, just dealing with equilateral and equiangular. If it's equilateral, then it's equiangular. If it's equiangular, then it's equilateral. These can be proven really quickly, basically using the base angles theorem and the transitive property. Find x and y. All right, so if all these angles are the same, then all these sides are the same. So that would mean that's 4 for y. And then since these two angles are the same, the base angles, then the side lengths are the same. So all 4 of K and L, triangle KLN, are all 4. And then this guy right here is isosceles. So x would have to be 3. That's all I got for you guys. Thanks for tuning in to 4.7. 4.8 may or may not be on this test. We're going to work on it, but every year I kind of switch up with how I want to choose to go about 4.8. So this could be the last section for your tests. Thanks. Bye now.